In this lesson, we'll go over how to detect motions with a motion sensor. We will need the following for this lesson: an ESP8266 development board, PIR motion sensor, breadboard, and some jumper wires. Let's go over how motion sensor works. It has two buttons. Button on the left side is used to control the delay. If you turn the button clockwise, it'll increase the delay, and if you turn it counterclockwise, it will decrease the delay. If you turn it clockwise till the end, the maximum delay will be approximately 5 minutes. If you turn it counterclockwise till the end, the delay will be approximately 3 seconds. Button on the right side is used to control the sensitivity. If you turn it clockwise, it'll decrease the sensitivity, and if you turn it counterclockwise, it will increase the sensitivity. The minimum range is 3 meters while the maximum range is 7 meters. Now the schematics of the motion sensor. The motion sensor has 3 pins. The pin on the left is VCC, which stands for Voltage Common Collector. The center pin, which is white, is the data wire. The pin on the right, the blue one, is the ground. One important thing that we must know about the PIR motion sensor is that it only works with 5 volts. It does not support 3.3 volts. So we have to make sure that we get enough power to PIR motion sensor for it to work. Since we need 5 volts for the PIR motion sensor, we have to connect to the positive of the breadboard with the VIN pin of ESP board. The VIN pin is the one that gives 5 volts from the ESP8266. Here we're connecting the ground pin to the negative of the breadboard. Then we will connect the VCC of motion sensor to the positive row, and the ground of motion sensor to the negative row. Then we have a white wire running from the motion sensor's data pin to ESP8266 D1 pin. And this is the complete schematics for working with the motion sensor. In real life, this is what it actually looks like. Now let's go ahead and code something to utilize the motion sensor. Open the eExplorer, connect ESP8266 development board, and open a new file. Define a local variable motion pin and give it a value of 1 since the data pin it is connected to is D1. Then define a local variable duration and set it to 1000 milliseconds, which is 1 second. Next, write gpio.mode and give it 2 parameters, motion pin and gpio.input. With the LED module, we use gpio.output as we were sending the signal to LED. But in this case, we're receiving data from the motion sensor, so it is a gpio.input instead. Next, we'll create a timer function with tmr.create, open and close parenthesis, colon, alarm, and give it 3 parameters, duration, tmr.alarm_auto, and function. And inside the function, we'll define motion status as gpio.read and pass motion pin as its parameter. This will read value from the motion pin. Next, we'll write an if statement to tell us whether motion was detected or not. So if motion status is equal to 0, then it will print no motion detection. Else, it will print motion detected. Then, of course, we have to end the if condition and the function itself. And we're done. Let's save this as motion.lua. As we were already connected to ESP8266, the file will automatically transfer to the board and start printing values every 1 second. It will print whether it has or has not detected motion every 1 second. In the next lesson, we'll control the state of LED using the motion sensor. If you have any questions, let us know on the IoT4E Community Board. Thank you.